And so what are they studying here exactly?
So we call this place a traditional knowledge guided laboratory. There are dozens of laboratories of this kind in this country. And so what is so special about the laboratories in this building, and what is so special about their work? I believe that the unique thing about the way in which colleagues in this building work is that their starting point is respect for traditional knowledge, and they start with a traditional knowledge proposition and then try to see to what extent can scientific tools explain or understand that traditional knowledge proposition. Sometimes they come out with very new and interesting results. So for example, we have quality standards for a plant which is very commonly used in medicine called curcuma longa or turmeric. In households, every household in India uses this plant in cooking, the yellow powder of turmeric. Now, in the traditional medical literature, this plant has names like Nisha, Rajni. And these are Sanskrit words, and what they mean is night, night collection. So really, if you want to develop therapeutic quality standards for curcuma longa, the traditional advice is to collect it in the night and not during the day. And in the lab, we have studied what is the difference between a night collection and a day collection in terms of chemistry and biology. And we find that there is a difference. When we work in this laboratory environment, one obvious question comes to mind. We are often asked, do we use science to validate Ayurveda? I think that this question is an innocent question, but is a question that is not very well informed, because the people asking this question do not really understand the difference in the nature of science and scientific knowledge and that of traditional knowledge. And so they assume that traditional knowledge must somehow be something that is amenable to investigation by science. It's a very complex question, actually, but people don't realize the complexity of it. And let me try and explain our understanding of the relationship between science and the traditional medical knowledge, which I will refer to by the word Shastra. Science is essentially an investigation that relies almost entirely on sensory perception in order to understand physical or biological reality. It uses the five senses, and all these instruments that we have in this or any other laboratory in the world are nothing but the extension of the five senses. So it collects sensory data it claims to be collecting the sensory data in an objective fashion. That objectivity is achieved by instruments that are so calibrated that they can record a certain range of sensory observations in a fashion that can be repeated, because they are instruments calibrated in that way that anybody using those instruments for the same set of observations will get similar observations. So objectivity is claimed because the observations are impersonal. They are not made by an individual scientist using his own natural senses, but by standardized instruments that can collect observations, that can record observations in a standardized way. And so impersonality or objectivity is brought into the picture. We understand in science really objectivity in terms of the principle of impersonality. That means it is not dependent on a person. It does not depend on the so-called subjective whims and fancies of a person, but the data, the sensory data, is being collected by objective instruments which behave in the same way, irrespective of which person uses them or handles them. So science collects objective sensory data through the 5 sensory instruments, and then it uses the 6th human instrument, namely the mind, to process this data using tools like logic and mathematics to arrive at some conclusion. Now, the problem in the method of science is that sensory data is always limited. Every sense or every sensory instrument has a certain finite range in which it can observe, and that range cannot possibly cover all the dimensions of sensory phenomena that are actually available in nature. Also, most instruments are single in their dimension, just as the human senses are also singular. The ear cannot see, the eye cannot hear, the nose cannot eat, and so on and so forth. So every sense has its own domain. Every instrument also has its own domain and a finite range. However sensitive we make the instrument, nevertheless, you can extend its range, but the range still remains limited. Therefore, one never is able to collect complete or whole information about any natural phenomena through the methods of science. One always collects partial information. Of course, this information is extremely detailed and is very useful. Now, when you have partial information about any phenomena, then we attempt to integrate that partial information by the use of logic, by the use of mathematics, new mathematical tools. We have integral calculus, for example, and many other sophisticated methods to integrate that data. But no matter what tools of logic or mathematics are used, when you are trying to integrate partial data, you can never recover the whole understanding of the phenomena that was under observation. So, in philosophy of science, we recognize that modern Western science is reductionist in its view. Now, this is not to belittle science. Reductionist view of any phenomena can also be very revealing. It is very fascinating, for example, to study the cellular structure of cells of living organisms in such a great detail, and this helps us to reconstruct, to get an insight into the way in which living organisms work. It does not give us molecular biology or cellular biology, does not give us a complete understanding of how the human or any other living system works, but it gives us a very, very reasonably deep insight into cellular mechanisms, into cellular functioning, and so on and so forth. Now, we use this knowledge, partial knowledge, with the integration that we might do, and we arrive at certain understanding. And the entire biomedical sciences, for example, are based on this understanding. Now they are functional. They do solve certain problems. Do they solve them completely? Perhaps not. So we would find that whatever be the mode of therapy that we use, whether it is chemicals, whether it is cells or genetic therapies, while we may get certain desirable results, we also often encounter the problem of what is generally called side effects. And the reason why side effects must exist is that we cannot know the effect of a part solution on a whole phenomenon. And whereas that solution may work on a particular target, but what does it do to the rest of the organism is something that cannot be fully predicted. In pharmacology and toxicology, we do design certain tests to ensure that any intervention that we do based on biological or biomedical sciences should not have a fatal result. And so therefore we have various schemes for testing and for biosafety. But no biosafety scientist can ever claim that the tests are absolutely safe. In fact, most drugs that we pick up in the market declare the level of safety of the drug, and they point out that the drug has to be taken with such and such limitation, or for such and such duration, or in such and such dose, because it would have side effects. And even taken in the prescribed dose, they would still have certain side effects, but the side effects are assured to be seen that they are not going to be fatal. But you can't get away from the problem of side effects. This is because science has not designed its interventions based on a whole understanding of a phenomenon. It has designed its interventions based on a partial understanding of a phenomenon. And when you design interventions based on this kind of reductionist understanding, you can achieve only limited success, and you are bound to encounter so-called side effects. All that side effects really mean is that we don't know how a particular intervention will act on an entire system, because we have no means to study it fully, and B, the intervention itself is designed on the basis of partial knowledge. Traditional knowledge, on the other hand, and we are talking of the field of medicine in which this institute works, also uses the same 6 instruments that any human being has, the 5 senses and the mind. But they use them differently. The starting point for a traditional scientist, and these buildings are named, as I informed you, after Vyasa and Nagarjuna and so on and so forth. These were great scientists. But the starting point for any work on traditional knowledge or traditional science, if I may use that word, is preparation of the mind. Not merely preparing the mind in terms of developing mastery over tools like logic or mathematics, which were and which are already there in Indian knowledge systems. We have very sophisticated schools of logic like Nyaya, Vaisheshika. We have very sophisticated mathematical tools, but it's not enough to have logical and mathematical tools in order to engage in science. There has to be a very intensive training of the mind, and the mind is understood in terms of several levels or states of the mind. Mathematics and logic are tools that can be used in a rational state of the mind, or to establish a rational state of the mind. And the rational state of the mind is certainly extremely important. Reason is certainly very important for everyone to understand some phenomena. But the rational state is only one of the states of mind, and is in fact, in knowledge terms, perhaps the lowest state of mind. It is a state of mind which is employed to explain, to communicate a phenomenon. It is not a state of mind which is used to derive knowledge. To derive knowledge, one has to go into deeper states of mind. And in Indian knowledge systems like yoga, several states of mind are explained. And the analogy that we use is like that of a pond, a deep pond. The rational state is somewhere at the surface or just below the surface of the pond. But there are so many other levels and depths to which you can dive into the pond, and the entire mental environment changes as you change the level and depth at which you are swimming in that pond. And just like today in chemistry, we have realized that the so-called nanochemistry, which is a different level at which one is looking at subatomic particles, nanochemistry is an entirely different kind of a chemical environment, has completely different rules and laws from the normal chemistry that we work with, because the entire environment is entirely different. We are looking at nano-sized particles, and they behave very, very differently from the normal kinds of atoms and molecules that we are used to working with in conventional chemistry. So the training of the scientist's mind is the first starting point in the traditional sciences, and there are ways of knowing which are far beyond the way of knowing through merely logic and reason and inference and mathematics, which is just an extension, a numerical aided extension of logic. So in these ways of knowing in which the mind is employed, the senses also behave a little bit differently. And although in traditional sciences we don't have any instruments like we have in laboratories to look at and increase the range of sensory perceptions. The senses themselves, in a certain state of mind, are able to feel, for example, or touch or taste with far more sensitivity. A restless mind, if you give it something to hear, hears something in a certain way, but a very calm and meditative mind hears things that the restless mind does not hear. The tongue tastes things as they travel down into the gastrointestinal system and can discern whether a substance eaten is causing an endothermic reaction or an exothermic reaction. This is one of the primary ways in which the properties of materials are understood in traditional knowledge. For us to use any material as a drug, we must know whether the drug is exothermic or endothermic. In lay language we say, is it hot or is it cold? If we don't know this polarity of hot and cold, we cannot properly use any drug. But in modern drug discovery, it is not necessary for us to find this kind of exothermic or endothermic reaction of any material, of any food. So what I am saying is that in a sensitive, meditative state of mind, the senses also behave differently. And therefore, the knowledge system that is constructed is what we call more holistic rather than reductionist. It becomes holistic because the mind is not analytical, it is not breaking up. The mind is in a holistic state. It sees things as they are. It doesn't see them in fragments. It doesn't see them in parts. And seeing things as they are in a holistic way can be achieved when you dive deeper and deeper into the layers of the mind. So our way of looking at the human body is quite different from the way in which Western sciences look at the human body. In Western sciences, we look at the human body in terms of its cellular, molecular, atomic configuration. So you add up parts and try to construct the whole. So the building block of the body is a cell. The cells become tissues, the tissues become organs, organs together build systems, several systems together constitute the body. And so you know about parts of the body, but yet you don't know how the whole body operates. In traditional medical knowledge, we look at the body in terms of certain flows, certain fields. It is a systemic theory of the body. The whole body is a homeostasis between three functions, what we call Kapha, Vata and Pitta. These are anabolic, metabolic and neurological functions. And you loosely try to correlate these terms with terms of modern biology. So we look at a body in terms of its particular permutation and combination of states of matter, entire states of matter, not as permutation and combination of cells or atoms, but in terms of permutation and combination of states of matter. The whole of nature we see as only consisting at the physical and biological level of 5 states. There is the state at the grossest level, which is the solid state, and then that solid state gets transformed into a liquid state, and the liquid state gets transformed into a plasma or a heat state. That plasma state can get transformed into a gaseous state, and that gaseous state can then get transformed into an ethereal or an empty space, a state where there is empty space. And all these 5 states are just transformations of each other, and they have a certain direction. It is from the solid that you transform to liquid, that is the flow, liquid to plasma, plasma to gaseous, gaseous to empty space. That's the order from the bottom up, and from the top down it comes from space into gaseous state, into plasma, into liquid, into solid. Now this is another way of looking at nature in terms of its 5 states, and we see human beings, plants, soils, mountains, water, any natural phenomena as a permutation and combination of these 5 states. We can tell you which body has which proportion of these 5 states depending on its morphology. And the same can be told from the morphology of a plant, the same can be told from the morphology of a rock, of a soil, of an animal, of a mountain, of a habitat. So this is a theory, just like the atomic theory can be used to try and understand the atomic structure of any substance. Just as the molecular biology can be used to tell about the cellular structure of any substance, so also you can tell about the configuration of the 5 states in any substance, because that every configuration has certain characteristics. And just as when atoms are very tightly bound, you get generally a solid state. And within those solid state, when the configurations are different, you get a whole range of chemicals which are described in the periodic table, depending on the bonding of these atoms. So in a similar fashion, there are characteristics of different substances depending on the configuration and in the way in which these 5 states bind. Now, looking at nature in terms of these states tells us that the nature of the knowledge is that of a field theory, of a systemic theory. It is somewhat like the quantum physics theory, as different from the Newtonian physics theory. And so now the question, can science validate traditional medical knowledge like Ayurveda? Is like asking, can Newtonian physics be used, a structural theory, be used to evaluate a quantum theory, which is a field theory? The problem is of that kind. There is certainly a relationship between structural theories and field theories. In more simplistic language, there is certainly a relationship between the part and whole. There is certainly a relationship between reductionist knowledge and holistic knowledge. They are not two different categories. They actually lie on a continuum. A reductionist theory can look at aspects and parts of nature. A holistic theory, a field theory, a systemic theory, can look at larger phenomena, can look at whole phenomena. But the whole and the part are evidently related. But the important thing in this whole dialogue between traditional knowledge and science is to understand the nature of the relationship between the whole and the part. And the trap is to avoid the idea of equivalence. The moment you say that a concept of science is equal to a concept of traditional knowledge, then it's like equating the part to the whole. That is obviously going to lead to distortion, because when you equate a part to a whole, you reduce the whole to the part in that equation. The whole is at least equal to a sum of parts. And even the sum of parts don't really add up to make the whole. There is no way to reconstruct the whole even by summing up the parts. And yet, and I must emphasize this, and yet there is a relationship between the part and the whole. In traditional knowledge theories, they actually say that the part is related to the whole, and the whole can also be seen in the part. There is a relationship between the microcosm and the macrocosm. But that's a different way of looking, of trying to see the whole in the part. That is not one of the subjects of inquiry of science. But in traditional knowledge, we recognize that even in a cell, you may be able to see the holistic aspects of its functioning. But then you must know what to look for to be able to look at that whole in the part. So in this laboratory, we function with a clear understanding that we are not going to find a one-to-one correspondence between a traditional knowledge concept or category and a scientific category. If you step out, I will explain it to you what I am trying to say with an example of, let us say, a plant.
Okay, let us do that.
Plant, and it's a plant which is very widely used in traditional medicine. We call this plant gugulu in traditional medicine, in Ayurveda, and the botanical name is Comnifera whitei, and it is the gum from this plant that is used. Of course, this is a desert plant, it's an arid area plant, not this is not the right habitat for this plant. It grows here, but I don't know when it fully grows whether it will yield the medicinal gum for which it is famous. But now this plant, the properties of this plant in Ayurvedic pharmacology are explained. There is a term, it says that this gum is meha hara, that is the Sanskrit word, meha hara, and that means that the plant works on fatty tissues. It does something to fat metabolism. So we say this is a plant which has properties which are very good in the field of fat metabolism, metabolism of fat. Now in modern pharmacological terms, they find this very vague. They say, how can this plant be working on the whole field of fat metabolism? Can you be more precise? And then they would make a suggestion that perhaps this plant can reduce the cholesterol, which is a fatty deposit, fat deposit, a particular kind of a fat deposit. And then we can do a experiment, and we find that this gum does reduce the cholesterol levels. So they say this is the science. You were saying something very vague, fatty metabolism or fat metabolism. Actually, it only works on cholesterol. Now, this is an example where the whole has been reduced to a part. Cholesterol and that kind of lipid is one type of fat in the whole field of fat metabolism. Indeed, as per Ayurveda, this does work on the entire field of fat metabolism. And not merely on one point in the field, which is the cholesterol level. But because scientists don't understand the difference between a field theory and a structural theory, they find it difficult to appreciate the fact that there could be a knowledge system which has identified the properties of a material at a field level. And so they tend to reduce it to a point in the field, which is the cholesterol. Now, if you wanted to do a proper experiment in a good traditional knowledge and science lab, which had the right spirit of understanding, then the hypothesis should have been, let us identify at least a number of points on the field of fat metabolism and test whether it works on all those points, rather than reducing it to one point, in this case, lowering of the cholesterol level. But people don't have the imagination or don't believe that there is a knowledge system which knows the systemic activity of a material. And so they don't even construct such an experiment. Now, in our lab, when we do examine a traditional knowledge proposition, we never do one-to-one correlation between meha hara, in this case, and cholesterol. That is a one-to-one. You have reduced a field activity to a point activity. We don't do it that way. We say if it's a field activity, let's at least look at several points, because several parts may add up or bring you closer to the whole. It cannot be one-to-one. If you do one-to-one, it means you are using the equation part is equal to whole. And when you use that equation part is equal to whole, you reduce the whole into the part. And the genuine teachers, scholars of traditional knowledge say, we don't want to cooperate, we don't want to collaborate, you are destroying, reducing our knowledge. We don't want to have any interaction with science. That is what happens. But that has been the problem of the relationship between traditional knowledge and science for several decades, at least in the field of medicine. For decades all over the world, scientists have been reducing holistic concepts, categories, properties into structural concepts, properties, and so on and so forth, reducing the whole into the part. And then only those spineless traditional scientists who are prepared to sacrifice their knowledge and get co-opted into the world of science because it is more prestigious, cooperate. The truly knowledgeable people who have dignity and respect for their own knowledge system refuse to cooperate. And so there has been a hiatus. There's been a very conflicting situation. But they need not continue to remain in this conflicting way if people trained in the epistemology of knowledge systems begin to understand the nature of traditional knowledge, that while it is using those 6 instruments of knowing, It uses the mind in a different way. It recognizes that when the mind is at a different state, is in a different state, its understanding and its view of reality also changes. In a rational state, the mind is practically blind. It only relies on the senses, and the senses obviously see things only in compartments, only in singular dimensions. And then all the mind does is does some addition and subtraction, does some inference. It does not try to see. So that state is the most insensitive state. It is a good state for the purpose of explaining something, but not at all a good state for understanding anything in depth. It is not a sensitive enough state. And unfortunately, our modern university systems and educational establishments don't show you how to train your mind to experience its different states. They don't even know that the mind has different states. And this brings me to another subject that is being also studied in this institute, which is about the relationship between the brain and the mind. In modern biology, neurobiology in particular, there is no such thing as the mind. The mind is nothing but a neural activity of the brain. And every so-called mental phenomena, an emotion, for example, can be detected as a particular kind of a neural activity in a particular part of the brain. And so they say all so-called mental activities are nothing but neural movements and neural dynamics, and you need to know a great deal of physics and mathematics to study the neurobiology today. It is not enough to know biology. If you don't know physics or mathematics, then you can't study neurobiology. Now, while it is true that the mind may be reflected in neural activities of the brain, to consider the brain and mind to be one is as absurd to a traditional knowledge holder as it is for someone to declare that a car and a driver are one, merely because when the car moves and you watch it from a distance, you don't see the driver and you only see one object of the car moving, and you think the car moves by itself and has all the mechanisms within to do its movements. But we know, of course, for a fact that the car and the driver are distinct. And while they work in conjunction, and there's no meaning to a driver without a car, or vice versa, nevertheless they are two separate entities and they can be separated. A driver can park his car and step out. So in traditional knowledge systems, the mind and the body and the brain are two distinct entities. And not only are they distinct, but they are separable. They are separable in life, and they certainly separate in death. And in traditional knowledge systems, at least in India, like yoga, a great yogi can actually step out for a certain period of time from the body and take his mind out. And it is the fontana from where he steps out and come in again. And so the mind is not seen in all traditional sciences as a biological object. We don't know what kind of an object it is. It's not a physical object. It's not a biological object. And at least in terms of our present understanding of science, we are forced to use the word, perhaps it is some metaphysical object, but an object it is. Even in traditional knowledge, the mind is a material thing. but it is not made out of physical material, it is not made out of biological materials. And so we really don't know what kind of a material it is to describe it in the language of science, because science doesn't have the tools really to know it, and the traditional knowledge systems themselves also don't have any tools either. They have the ability to separate the mind out. They have experience of what the mind is. They have experience of different states of mind. But there is no description except to say Chidarupam, that it is a very, very Chid means it's like a very small thing. It's a very small thing. It's a very small object. A very sub-atomic kind of a size. Chidarupam. Its form, Rup is Chid. Very, very small. Chidarupam. But this is a big difference, in the way in which mind is understood in traditional knowledge systems. That it is an entity, it is distinct from the brain. It can give rise to so many different states. Each state of the mind has different properties. And of course today a lot of people are beginning to get access to some experience related to this through the promotion of things like yoga and Tai Chi and, generally knowledge systems coming from traditional societies. In this part of the world, it is from India and China. And I'm sure there are traditions that are there in Africa and in South America and even in Europe itself. If you look at European cultural history, you would find that in perhaps the Jewish or the Egyptian traditions, they also knew and had experience of these different states of mind and so on and so forth.
Thank you.